Hello students, welcome to TMC Hub. Today I am here to explain you one of the most important concepts in aptitude. If you want to write any competitive exam or any government exam, you should solve the questions within the specified time. Okay, so of course lot of students can solve the questions when there is no time period is given to you, but in competitive exams we have the time limit. So we need to solve the questions within the time phase only. Okay, so by the way, a lot of students may thought that by using the shortcuts we can solve the questions within the specified time, but that's not the truth. You can't solve all the questions by using the shortcuts only. Only you can solve the 10 to 15% of the questions in your exam by using the shortcuts method. So you can solve some of the questions by using the shortcuts method. Of course, we can solve some problems by checking the unit digit in the given options. And for some problems we go with the approximation method where the lengthy calculation related problems are given. We can have number of things to do. But today I am going to explain you one of the most important concepts. I would say that this is a killer concept because for a lot of problems we can solve it by using this concept, which is called as digitsum concept. So okay, popularly known as DS concept. So this is a killer concept because minimum 40% of your problems we can solve it by using this concept. Okay, for that you need to understand it few things before we go to the actual problems. How do we apply it? Normally, if you write any competitive exam, we will be given 4 different options. 4 or 5 depends on the exam. Any exam if you write it, competitive exam, will be given that options, right? So actually this concept, by using this concept, we can eliminate the options. Okay, so by using this concept, what will we do? So we can eliminate the options. You write any competitive exam in India, so definitely you have quantitative aptitude as integral part of your syllabus. You can't separate aptitude from your subject. I mean, you write any exam, definitely you have aptitude as integral part. You can't separate it. So that's why every student who are supposed to prepare for, or who are preparing, or who is willing to prepare for the government exams or competitive exam must learn this concept. Trust me, this is a magical concept. We can solve lot of questions, lot of problems by using this technique. Now in this video, I am going to provide each and every detail related to the digitsum concept. So we have some properties regarding this digitsum concept before we go to the actual problems, how we apply this digitsum concept and different problems. Okay, digitsum, or we can also say it as DS or digitsum concept. First of all, what is the digitsum definition? A single digit obtained by adding all the digits of the number is called a digitsum. So it's a simple thing. Suppose if I take a number 431. So digital sum is nothing but by adding all the digits we get the resultant value, that is nothing but the digit sum. So 4 plus 3 plus 1 is what? 8. So here I can say that the digit sum is what? 8. If you take any number, for any number if you are adding the digits, the final sum is nothing but the digit sum. Digit sum is nothing but, in simple words, add the digits. That's it. That is what the digit sum means. That. So you can take any number, like suppose if I take that 43214. What is the digit sum of this number? So 4 plus 3 is 7. So 3, let me take that 43214. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 4 is what? 14. 10 plus 4 is what? 14. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 4 is what? 14. So by the way, whenever you express the digit sum, so the digit sum should always be a single digit. It should be always expressed in single digit only. That means that you always express it as from 0 to 9 only. So here I get the total sum of these digits is 14, but you have to express the final number as a single digit. So here I have the number 14. So now you add this number again, add the digits again. 1 plus 4 is nothing but what? 1 plus 4 is nothing but 5. So the digit sum of this complete number is what? 5. So the digit sum is nothing but by adding all the digits of the given number. And we can also express the same thing. So another definition. So which is nothing but the remainder obtained by dividing the given number with 9. the remainder obtained by dividing with 9 is called the digit sum. If you take some example, again if you take some number, let me take the 236. Okay, so generally the digit sum is nothing but what? Add the number 6 plus 3 plus 2 is, which is nothing but what? 11. 11 means that we always have to express it as a single digit. 1 plus 1 is what? 2. Okay, this is one way. The other definition is by dividing the given number with 9, the remainder is nothing but your digit sum. If you divide this complete number with 9, so then we'll get what? Then the remainder is 2. Then the remainder, you can just divide 236 with 9, we'll get the remainder 2. Okay, so the definition of digit sum, either we can write it as a single digit obtained by adding all the digits of the number, or when we are dividing the given number with 9, the remainder obtained is nothing but what? Your digit sum, right? So whenever you are dividing with 9, so you know the divisibility rule of 9. What is the divisibility rule of 9? The sum of the digits in the given number is divisible by 9, then the complete number is divisible by 9. Okay, so suppose if I ask you that what is the remainder when I divide with 9? What is the remainder we'll get when this number is divided with 9? So generally what we do is we completely divide the number with 9. So just because we know the divisibility rule of 9, we can apply the concept of divisibility rule of 9. What is the divisibility rule of 9? Sum of the digits. So wherever you get the sum of the digits is 9, we can cancel out those number. Right? Suppose if you see this number, so here this is 432, 14 divided by 4. I am dividing with 9. So wherever you get the sum as 9, you can cancel out that number. 4 plus 3 plus 2 is what? 9. So you can cancel out the numbers. So you just take the remaining number. 1 plus 4 is what? 1 plus 4 is nothing but 5. 1 plus 4 is what? 5. So this is nothing but the remainder when I divide 432 14 divided by 9. When I divide 432 14 with 9, the remainder obtained is what? 5. For that, actually you don't need to separately divide with 9. So you can take the digit sum again, because the divisibility rule of 9 is nothing but sum of the digits. If the sum of the digits in the given number is divisible by 9, then the whole number is divisible by 9. Okay. In both the ways we can express the digit sum concept. Of course it is not required for us. The only thing is we can directly take the digit sum. Alright. Suppose if you take that 431. So what is the digit sum? So 4 plus 3 plus 1. The digit sum is what? 8. Even if you divide the same number with 9, we'll get the remainder is 8. Again, if you take the number 236, 6 plus 3 plus 2 is what? 6 plus 3 is 9, 9 plus 2 is what? 11. So because we have to express the digit sum as a single digit, 11 means that I have to express as a single digit, that is nothing but 1 plus 1. 1 plus 1 is what? 2. So the digit sum is what? 2. Of course, we can also divide with 9, we'll get the same number. Okay. By the way, when I take the 236, this number 236, and there is an important point. Whenever you are adding the digits, wherever we get the digit sum is 9 or 9 multiple, we can actually cancel out that numbers. Like suppose if you take the 236 number, so 3 plus 6 is what? 9. So I can cancel out this number. The remaining number is what? The remaining number is 2. So the remaining number is 2. So which is nothing but your DS, digit sum. Okay? You remember one point. So whenever you are adding the digits, if the digit sum is, while adding the digits, if we get the digit sum, sum of the numbers, if sum of the numbers digit sum is 9 or 9 multiple, we can actually cancel out those numbers. Okay? Let's do more examples and you will understand it. So this is the basic definition of digit sum. So the properties of digit sum is, what are the points we need to remember in the digit sum concept? So the digit sum should always be expressed as a single digit. As I already mentioned that we always express the digit sum as what? As a single digit only. That means that you have to express the sum either from 0 to 9. You have to express it from 0 to 9. It should be only a single digit number, right? The next one is, if you get digit sum is 9, then we can take it as 0. This is another important point we have to remember while doing the problems on digit sum. Okay, suppose if I just take the number, if I adding this number, what is the digit sum of these numbers? The digit sum is, so wherever the digit sum is 9, you can cancel out 9. right? So one single number 9 is there, so I can cancel out that number. The remaining number sum is what? 4 plus 3 plus 2 is what? 9. So 4 plus 3 plus 2 is 9, so I can cancel out the number. So we have left with nothing, right? So that means that what is the portion we have left with? 0. So when I take that 432 only, what is the sum? So we can cancel out 4 plus 3 plus 2. This sum is 9. So all the numbers we can cancel out. So that's why we can express 9 as 0. Okay. So 9 means that you can take it as 0. 9 means that what? You can take it as 0. Let's say this is example 9 plus 4. If I take an example 9 plus 4 is 9 plus 4. So 9 plus 4 is equal to what? 13. 13 means that 1 plus 3, because we have to express the digit as a single digit. Digit sum as single digit. 1 plus 3 is what? 4. The digit sum is what? 4. If I take 9 plus 4, if I add 9 plus 4, I'll get the digit sum is what? 4. The same thing 9, instead of 9, if I take 0. 0 plus 4 is equal to what? 4 only. We get the same digit. Right? We get the same digit sum. So the point here is, whenever you see the number 9, or wherever the digit sum is 9, we can also express 9 as 0. In digit sum concept, we can express 9 as 0 or 0 as 9. Okay? You remember that point. So 9 plus 4, you see that the digit sum is 4, 13, 1 plus 3 is 4. So instead of 9, I can also take that 0. 0 plus 4, still I get the same digit sum, 4, right? And similarly, even if you multiply, so 9 into 6 is what? 9 into 6 is 54. What is the digit sum? So if I take that 9 into 6 is what? 54. Suppose if I take 0 instead of that, 0 into 6 is what? 0. 5 plus 4 is what? 9. As I already mentioned that, so 9 can be taken as what? 0. 5 plus 4 is 9. 9 or 0, both are same. Do I get the same resultant values? LHS is equal to RHS, right? So which means that while you are doing problems on the digit sum, you can take 9 as 0 or 0 as 9. Okay, in the digit sum concept, 9 and 0 both have the same meaning. So that is the next point we have to remember. Let's go to the next property. So we can apply digit sum concept for any mathematical operation such as plus, minus, into and division. Okay, we can apply digit sum concept for any mathematical operation such as plus, minus, into, division, which means that when you are doing problems related to the addition, or when you are doing problems on the subtraction, or when you are dealing problems with the multiplication, or when you are dealing with the division, for all these mathematical operations, fundamental mathematical operations, we can apply digit sum, right? So the next point is we can use digit sum concept only for accurate values, not for approximate values. The next point is, so when you are applying the digit sum, you should not apply for all the problems. Okay, probably if you read the problems in the brackets, you may see that like, so approximate value. Okay, express your answer in approximate values. When you have been given such kind of questions, so we should not apply this concept. Do you understand it? We can actually use this concept only for the accurate values, exact values only. Of course, in our exams, 90% of the problems are the exact values only. Only 10% of the problems we have it approximate values, right? So 90% of the problems will have the accurate values. So by the way, the point need to be remembered from this digit concept is the next properties. So the digit sum should be applied for the accurate values only. That means that exact values only. If the problem is asked for the approximate values, you should not apply this concept. Please keep it in your mind, right? The next point is, so the ds can also be a negative value. Sometimes when you are doing mathematical operations, so maybe the digit sum will get as a negative value. We can also apply for the negative values. But how we should apply for the negative values? Suppose if you see that an example 753 minus 476. So the number is here 753 minus 476. Suppose if I subtract these two numbers from 753, if I subtract 476. So the resultant value is what? 277. Suppose if you do it, so we'll get 276. Let's see that what happens. I'll go by the digit sum. So this is the main calculation. If I go by the, this is the LHS part, this is the LHS left side part, and this is the right side part. By digit sum also we can prove that both are same. Like how we see that. Suppose if you see that, so let's take the digit sum of left side part. First you take the digit sum of 753. So what is the digit sum? 7 plus 3 is 10. 10 plus 5 is 15. 15 means that what is the digit sum? 6 is the digit sum. 7 plus 3 is 10. 10 plus 5 is what? 15. 15 means that what? So 1 plus 5, which is nothing but what? 6. And similarly, if you take this number, so 6 plus 4 is 10. 10 plus 7 is what? 17. 17 means that what is the digit sum? 8. Now I get the digit sum is what? 6 minus 8. 6 minus 8. Generally 6 minus 8 means that what? 6 minus 8 means that minus 2. 6 minus 8 means that what? Minus 2. So this is the DS. The final DS value. When I say that DS is nothing but the digit sum. DS is what? The final digit sum is minus 2. When you get the negative value in the DS, then you have to subtract it what? See, generally minus 2 is what? 0 minus 2 is equal to minus 2. Right? So 0 minus 2 is equal to minus 2. So as I already mentioned that 0 can also take it as what? 9. So 9 minus 2 is equal to what? 7. So instead of 0, I can also take it as 9 in the digit sum concept. So whenever you get a negative value in the DS, then immediately subtract that value from 9. Then that is our final positive DS value. Right? So here I got minus 2. So when I have to express in the positive value, so that should be what? 9 minus 2, which is nothing but what? 9 minus 2, which is nothing but what? 7. Minus 2 plus 7, both are same. So by the way, you can check it here. When you check here, as I mentioned that whenever there is a sum 9, wherever the combination sum is 9, you can cancel out. Then what is the remaining number we have left with? 7. So what is the left side part digit sum? The final value is 7. And the right side part also what? 7. So both are same. Okay. So we may get the negative sum as the DS value. But when you are getting the negative value as the DS, so you have to express in the positive value. How you express it as a positive value? By subtracting that number from 9. I got the DS value is minus 2 here. So whenever I get a negative value, so subtract the negative value from 9. That is your positive DS value. So here I have the value of minus 2. So 9 minus 2, 7 is your DS. So you will get anything. Like let's say that suppose if I get minus 3 as a DS. So then what is the positive DS value? 9 minus 3 is the positive value. Right? So similarly if I get that minus 4 as the DS value. If I get DS value as minus 4, then what is the positive value? 9 minus 4 is 5. 5 is the positive value. Okay. So this is the next property we had to remember. And these are the points we need to remember. So before we solve the actual problems. Okay. See here. I said that so we can apply it for plus, minus, into and division. So we don't have any problem when you are dealing with plus, minus, into. But for division, we have to learn few more things. So before that, we'll solve some problems, how we need to apply the digit sum concept. Then we'll talk about the division. Okay. So first we deal with these three and then we'll go to the next one. Once if you complete this, then we can solve any question related to the digit sum. Actually, we can, by using this method, we can check the options. Okay. So we can't get the exact values. So only with the help of options we can solve the questions. Just because you are writing competitive exams where you will have that 4 or 5 different options, we can use this trick. For the conventional method, we can't solve the questions by using this method. Anyway, we are actually doing the problems related to the like objective type of questions. So that's why we don't have any problems. That's why this is a magical and killer concept. Let's go to the problems. Okay, let me start with a simple basic simplifications. Like if you take the first one, what is the value of 23 into 45 into 67? And you will be given option 69345 as the first option, 67432, 69445 and 67845. Okay, so you know the digit sum. So how do we apply the digit sum? Let's take the digit sum. So here I have the numbers 2 and 3. What is the digit sum of 2 and 3? 5. So by the way, you first observe the numbers 23, 45 and 67. So if you take the middle number 45, what is the digit sum of 45? 4 plus 5 is 9. I already mentioned that 0 or 9 both are same. 4 plus 5 is what? 9. So can I take it as 0? Yes, because when you are doing problems on the DS concept, 0 or 9 both are same. So 4 plus 5, 9, so I can take it as 0. So if one of the numbers is 0, when we are multiplying the numbers, 0 into any number is what? 0. I don't need to actually look at the remaining numbers because 4 plus 5 is 9, 9 can be expressed as what? 0. 0 into any numbers is equal to what? 0. So which means that the DS is value, the DS is what? 0. So now you check the options. Okay. So for this problem, for the given problem, the DS value is what? 0. Now you just look at the options. So just remember one point, when you are doing the DS problems, so we can apply the casting out of 9's model, casting out of 9's concept. Wherever the sum is 9 or 9 multiples, then we can cancel out those numbers. You remember that point. Here if you see that 4 plus 5 is 9, right? 4 plus 5 is 9. 4 plus 5 is 9, I can cancel out. 9, I can cancel out. 6 plus 3, 9, cancel out. So which means that I have left with nothing. So which means that what is the DS of these numbers? 0, right? So the first option clearly got the 0 as the digit sum. Same as expressed in the main problem. So by the way, we had to check for the remaining options. So just remember one point. So we don't get the different DS for all the options. Maybe we'll get the same DS value for 2 or 3 options. We have to check the remaining options too. It is not 100% we can solve the questions. Sometimes maybe the DS values for the 2 options are same, which is same as the main problem. So that's why we need to check all the options. You need to be little faster in the calculations. That is the only thing you have to practice. Here again, so if you take this one, 7 plus 2 is 9, I can cancel out. 6 plus 4 is 10, 10 plus 3 is what? 13. 13 means that what is the DS value? 13 means that, so 13 I'll get the digit sum. So as we need to express as a single digit, so 1 plus 3 is what? 4. So by the way, if you take the next one, 9 cancel out, 4 plus 5, 9, 6 plus 4 is what? 10. 10 means that 1 is the digit sum. So 10 I got it here, 1 plus 0 means that what? 1. And similarly, if you take that 4 plus 5 is 9 here. So 8 plus 6 is 14, 14 plus 7 is what? 21. 21 means that what is the DS value? 3. Okay, so you just add the numbers, that's it. So 6 plus 7 is 13, 13 plus 8 is what? 21. 21 I got, so but the single digit sum is 2 plus 1 is what? 3. So 3. So for the main problem, what is the DS value I got? 0. For the main actual given problem, the DS value is what? 0. If you check the remaining options, first option we got 0 as the digit sum. For the second option we got 4 as the digit sum. For the third one we got 1 as the digit sum. For the fourth option we got 3 as the digit sum. So which one is as same as the problem? The first one, right? So the first option is clearly the right answer. So generally if you multiply the numbers, it takes time, right? You can save a lot of time by using this method, right? When you are doing this simplification, so if you go by the conventional method, it takes a lot of time. But by using the simple trick, we can eliminate the remaining options, right? You need to be a little faster in the addition. It won't be a difficult number, so because the single numbers we are adding at a time. And also we have another thing which is useful for us is casting out of 9's. We can also apply it. So we'll do a minimum 20 to 25 problems, then you'll completely understand this concept. So it is not a separate concept. So this is not confined to only a particular concept, a particular topic. We can use it any concept, any topic. We can use this concept in any topic. Like it can be used in time and distance or time and work or number system, or you can apply it in averages, or you can apply it in the trigonometry, you can apply it in the geometry, mensuration, whatnot. Any problem related to the mathematics, definitely you can use this concept. Trust me, you can solve 30 to 40% of the problems by using this method. You can save a lot of time by using this method. Right, let's go to the next problem. Now you see that 5, 8 into 9, 6 into 6, 2. What is the digit, what is the final product? You will be given options. We know the conventional method, you have to multiply all the numbers. Now it is not required for us. So first you take this number 5, 8. What is 5, 8? 5, 8 means that, yes. So 5 plus 8 is 13. 13 means that what? 4. You just simply take the digit sum only. First number is 5, 8. So 13 is the sum. 13 means that what is the digit sum? 4. If you take the 96, 96 or 0, 9 or 0, always same, you can cancel out the number. What is the remaining number? 6. 6 and 2. What is the number? 8. So 4 6 is 24. So 24 means that again, no need to multiply each and every number here. So here I'll get 4 into 6 into 8. 4 into 6 is what? 24. 24 means that, here you see that 4 into 6 is 24. 24 means that what? 2 plus 4 is 6. Now this becomes 6. 6 into 8 is what? 48. 48 means that 4 plus 8, 12. 12 means that what? 3 is the digit sum. Okay, I'll explain it clearly. So 5 plus 8 is what? 13. So here I have that. Here I have that 13. 13 means that 4 is the digit sum, right? 4 here. Here I can cancel out the 9, which means that the remaining number is 6. So 4 into 6 is what? 4 into 6 is 24, right? 24 means that what is the digit sum? 2 plus 4 is 6. So which means that from these two numbers we'll get 6. 6 as the digit sum. Now 6 plus 2. 6 plus 2 is what? 8. 8 6 is a 40. 8 is the product. 4 plus 8 is what? 12. 12 means that what? 1 plus 2 is 3. So what is the DS value? The DS value is 3. So now we go to check the options. So just go with the, you can just check the options now. 4 plus 5 is 9 here. 6 plus 3 is 9. The remaining numbers are what? 4 plus 2, 6. I'll do a little faster. See, 4 plus 5 is 9. 6 plus 3 is 9. So 2 plus 2 is what? 4. And now if you see that 6 plus 3 is 9. 4 plus 5 is 9. So 2 plus 1 is what? 3. And 4 plus 5 is 9. 6 plus 3 is 9. 3 plus 2 is what? 5. So the main problem, digit sum is what? 3. For which option we have the digit sum is what? 3. That is for the option 3. So the right answer is what? 3. Do you understand it? Okay. So you need to be little faster while adding the digits. So if you are adding the single digits, so it won't be a difficult task, right? Probably if you are adding 2 digits or 3 digit numbers at a time, it may take time. But here we are adding single digits, right? It won't take much time. Actually, for this time of this kind of problems will be solved within fraction of seconds. So just you take the number. So 9, whenever you have the 9, you can cancel out the number because 9 or zeros both are same. And wherever the digit sum is 9, you can cancel out that numbers. So the remaining numbers is 6, 4, 3, 5. The digit sum of these options is what? 6, 4, 3, 5. So the main problems digit sum is what? 3, and now finally we got 3. So the third option is the right option, right? Now you do this problem. So tell me your answer. So 123 into 46 into 632. So what is the right answer? So do it fast. So here I'll go with that. So 1 plus 2 plus 3 is what? 6. 4 plus 6 is what? 10. 10 means that 1. Right? 4 plus 6 is what? 10. 10 means that 1 plus C. 1 plus 0. 1 plus 0 is what? 1. Now 6 plus 3 is 9. So wherever the digit sum is 9, you can cancel out the number. So what is the remaining number? 2. 6 into 1 into 2. 6 2s are what? 12. 12 means that what? 12 means that the DS is what? The DS is 3. The DS is what? 3. So now let's check it the options. Here I have that. So 5 plus 8. See, the digit sum either can be 9 or 9 multiple. You can cancel out that. So 5 plus 8 is what? 18. 5 plus 5 is 10. 10 plus 8 is what? 18. 18 means that 9 2s are 18. And then 6 plus 3 is 9. So what are the remaining numbers? 8 and 5. 8 and 5 means that what? 13. So 13 means that what is the DS value? The DS value is 4. Let's take the next one. So here again we have that 6 plus 3 is 9. 5 plus 8 is 18. Either it should be the digit sum must be 9 or 9 multiple. So which means that 9 or 18 or 27. When we have it, we can simply cast out those numbers, remove those numbers. What is the remaining number? 7 plus 5. 7 plus 5 is what? 12. 12 means that what is the value? So 3 is the value. Next, you can see that 4 plus 5 is 9. 6 plus 3 is 9. Okay, the remaining numbers are 6 plus 6 is 12. 12 plus 5 is 17. 17 means that what? 8 is the DS value. Now 4 plus, for this fourth option, 4 plus 5 is 9. 7 plus 2 is 9. 6 plus 4 is 10. 10 plus 1 is what? 11. 11 means that what is the digit? 6 plus 4 is 10, 10 plus 1 is 11, 11 means that 1 plus 1 is 2 is the digit sum. So for the main problem we have the digit sum is 3. So in which option we have the DS value is 3? The second option, right? The second option is the right option. Okay, now let's see the next problem. So 16 cube plus 17 cube is equal to which option? 16 cube means that what? So first of all you go with the digit sum. Forget about the cube number first. First you take the numbers, so 1, 6. What is the digit sum of this number? 1, 6. 1 plus 6 is 7. So which becomes what? 7 cube. 7 cube means that what? 343. So 343. So 343 means that 3 plus 3 is 6. 6 plus 4 is what? 10. 10 means that what is the value? 1. 17 cube. 17 cube means that now you go with the digit sum concept. 1 plus 7 is what? 8. 8 cube is what? 512. So 512 means that what? 5 plus 2 is 7. 7 plus 1 is what? 8. 8 plus 1 is what? 9. 9 or 0, right? So here I have 16 cube plus 17 cube. So even the numbers are given in terms of cubes. First we will take the digit sum only. 1 plus 6. What is the digit sum? For 1 and 6 the digit sum is 7. 7 cube is what? 343. Now the next number is 17 cube. 17 cube means nothing but 1 plus 7, which is nothing but 8. 8 cube is what? 512. So the digit sum of 343 is what? 1. The digit sum of 512 is what? 8. So 5 plus 2 plus 1 is 8. 1 plus 8. This is the final digit sum, right? What is the value? 9. So 9 or 0. So we have to check for the option. So in which option we have the digit sum is 0 or 9. So here 9 get cancelled, 9 get cancelled. So the remaining digits are 0. The digit sum is what? 0. For the first options clearly we got 0. And by the way we check the remaining options. 9 get cancelled, 9 get cancelled. 8 plus 8 is what? 16. 16 means that what is the DS value? 7. And similarly if you take that 6 plus 3 is 9. So you can cancel out. The remaining numbers digit sum is what? 1 0 0 means that 1 plus 0 is what? 1. So similarly if you take this one, 9 get cancelled. So 8 plus 2 is 10. 10 plus 6 is what? 16. 16 means that what is the digit sum? 7. Okay, so what is the right answer? We need to get the DS values either 9 or 0 because both 9 and 0 are same, right? The first option is clearly the right answer. Okay, do you understand it? So this is a simple trick, simple model. The only thing is we need to practice a little. So the digit sum is important. So you need to add the digits in the faster way. Then we'll get the answers within the fraction of seconds.